Hello class, welcome to Geometry Lesson 2.2, which is all about proving lines parallel. After this lesson, you should be able to use angle relationships to prove that lines are parallel. So today's lesson is going to tie in really closely with what we talked about in yesterday's lesson, Lesson 2.1, which was all about our angle relationships. And in that video, I talked about how if we have two parallel lines, some of the angle relationships are congruent, right? Alternate exterior angles are congruent, alternate interior angles are congruent, corresponding angles are also congruent. So those three always remain congruent if you have parallel lines. But now we are going to do the opposite, right? I'm going to give you an angle relationship and two measures and ask if these are the measures of these angles, are the lines parallel? So let's look at those theorems. So whenever you have the same exact idea, but it's just the opposite, so in this case, instead of saying that the angles are congruent because the lines are parallel, now we're going to use the converse of those things and say, if the angles are congruent, then the lines are parallel. So we have a converse of the corresponding angles theorem. So if we look, we have two angles that are corresponding, and if I say that they are congruent angles, that tells me that line L is parallel to line M. Remember, the vertical bars like that mean parallel. Okay. Then we have the converse of the alternate interior angles. So again, I'm giving you a pair of alternate interior angles. And if those are congruent, then line L is parallel to line M. So then we also have something called the converse of the alternate exterior angles theorem. So that means I gave you two exterior angles. And if those two exterior angles are congruent to each other, line L is parallel to line M. Then we have the converse of our same side interior angles postulate. So yesterday we talked about how same side interior or consecutive interior is another name for them, are always supplementary. If you add them together, they equal 180. So that only happens if two lines are parallel. So if I give you the measure for angle 1 and angle 2, and you add them together and they equal 180, that tells you that line L is parallel to line M. Okay, so congruent angles for alternate exterior, alternate interior, and corresponding all mean that the lines have to be parallel. And if our consecutive interior or same side interior angles are supplementary, our lines are also parallel. Now today we're going to learn about a new type of proof. And I can hear you guys groaning already, but I think you guys might like this type of proof. So it's called a flow proof, and a flow proof requires probably the least amount of writing out of all of the proofs that we've done, so that should automatically make you happy. And the way you start, you write the word proof. Okay, so that's your first step. Literally just write the word proof. Then group your given information together. So I copied down the given numerical expression, and then I wrote given underneath. Okay? Now let's look at our picture. We were given angle 1 and angle 2 are congruent, but we want to prove that line L is parallel to line M. And if you look all the way back up here, it's proof of Theorem 2.5, and Theorem 2.5 was our converse alternate interior angles. So that means that we're not going to be allowed to use alternate interior angles theorem to prove this, because we're trying to prove why it works. Okay, so I see that I was given angle 1 and angle 2 are congruent, and I'm trying to figure out how can I prove that line L is parallel to line M without using alternate interior angles. So if I look at my picture, I see I have another angle relationship. If I look at angle 1 and angle 3, those are considered vertical angles. So I'm going to say angle 1 is congruent to angle 3 because vertical angles my handwriting is terrible today. Let me fix that. So vertical angles are congruent. So vertical angles are congruent. I'm just going to write that right below it, okay? Now, I see that angle 1 and angle 3 are vertical. I'm going to look for, are there any other angle relationships? Or are my two pieces of information related at all? Well, I see I have an angle 1 is congruent to angle 2, and angle 3 is congruent to angle 2. So I think I can say angle 2 is congruent to angle 3. And what property is that? That is called the transitive property. Okay, so now it's called a flow proof because then you go like this and you say, I'm piecing those two first bits of information together to get to that third piece of information. So I use the arrows to point to the next step. So then if angle 2 and angle 3 are congruent, then I can say what? How are angle 2 and angle 3 related? Angle 2 and angle 3 are considered corresponding angles. And if we know that two corresponding angles are congruent, using the converse we talked about, we can say that our lines are parallel. So I can jump right into saying line L is parallel to line M, and that's by our converse of corresponding angles. And that is a theorem, so I'll just write theorem after. So that's our flow proof. You start with the given, look for some more information maybe from a picture or definitions or anything, and then use those things to conclude something else. So we used our first two things to use the transitive property to swap some stuff out, and then we looked at some more angle relationships to get to that third step. So that's called a flow proof. Now, we want to do some calculation type things with our problems. So we want to determine whether the lines are parallel. The problem that we're given, the edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edges of the sidewalk are parallel? Okay. So the way that the inspector can know is he can first measure all of the angles at the corners of the sidewalk, right? And if he does that, we can see that we have a 53-degree angle here and a 53-degree angle here. And if we're looking at the sidewalk, here's one edge, here's the other, and we want to know, are they parallel? So if we kind of outline our picture a little bit, you can see that we have two, I wonder if I move it. Does that look a little familiar, hopefully from yesterday? We have two parallel lines, maybe. We're trying to prove that. And then we also have a transversal. So let's look. I see I have 53 here and 53 here. How are those two angles related? They are alternate exterior because they're on the outside of the parallel lines and they're on opposite sides of the transversal. And they're both 53, so that means that they're congruent. And if alternate exterior angles are congruent, Using the converse, we can say that the lines are parallel. So we would say, since the two 53-degree angles are congruent, he can apply the converse of alternate exterior angles theorem, and the edges of the sidewalk are parallel. All right, now I want you to determine whether what the measure of angle 2 should be in order to guarantee that the sidewalk will be parallel to Main Street. So what does the measure of angle 2 need to be in order to guarantee that the sidewalk will be parallel to Main Street? Go ahead and take a minute and figure that out. Hopefully you looked and you said, okay, here are my parallel lines for the sidewalk and Main Street. Here's the line that cuts between. So 2 and 53 are alternate interior. And if I want those two lines to be parallel, my alternate interior angles have to be congruent. So angle 2 should be 53 degrees. Okay, we have two more theorems and one more example. So we have theorem 2.8, which is if two lines are parallel to the same line, then they are parallel to each other. That's kind of like the parallel version of the transitive property, right? If A is parallel to C and C is parallel to B, then A must also be parallel to B. Or you could do it in a different way, just with the way the arrows were drawn on the picture. That's why I did that order. But if you have one line is parallel to another, and that second line is parallel to yet another, the first and the third also have to be parallel to each other. Then we have theorem 2.9, which is if two lines are perpendicular to the same line. Okay, remember, perpendicular means meets at a right angle. If two lines are perpendicular to the same line, then they are parallel to each other. So if two lines are perpendicular to the same line, then they are parallel to each other. So if A is perpendicular to C and B is perpendicular to C, then A and B are parallel. So then example 3, solve a problem with parallel lines. If we look at this picture, when building a gate, how does Bailey know that the vertical boards V and W are parallel? So V is over here, and W is right here. And the picture, I'm a little mad because I pull these pictures from the book. They wrote in the answer on the picture, so I can get rid of that. But if we look at those two lines, we can see, so here's V, here's W, right? My smartboard's freaking out. Okay, V and W, we have these right angles. And remember, just like it said in the last theorem, if two lines are perpendicular to the same line, then they must be parallel. So V and W are both perpendicular to this line right here, therefore they must be parallel. Now, letter B, what should angle 1 measure be in order to ensure that angle B, or board B, is parallel to board A? So here's board B, here's board A, and then it's hard to see, this picture is not the best. That angle right there is 35, and then angle 1 is right there. So if I want them to be, those two boards to be parallel, I have consecutive interior angles here. And consecutive interior angles need to be supplementary or add up to 180 in order for our lines to be parallel. So I'm going to say the measure of angle 1 plus 35 equals 180. And if I subtract 35 from both sides, I am left with 145 for the measure of angle 1. That will make sure that board A and board B are parallel to each other. And then here's a nice little concept summary for you, just combining all of those theorems that we talked about, except for the last two. If you have any questions at all, please feel free to ask either myself or a friend, and have a great day.